Hashtag F-47 reached Mach 12.5 and the Pentagon went silent. 3 days ago, something happened over the Pacific Test Range that has military analysts around the world questioning everything they thought they knew about the limits of atmospheric flight. Rumors suggest America's most classified experimental aircraft didn't just break records, it shattered them. Mach 12.5 in sustained flight. That's 9,563 miles per hour. And here's the part that should terrify our adversaries and, frankly, might be keeping Pentagon officials awake at night. After the test, there was no press release, no official statement, no celebration, just absolute silence. The kind of silence that tells you something so significant just happened that the implications are still being calculated. Because when you achieve speeds that shouldn't be possible with current technology, you're not just advancing aerospace engineering, you're potentially rewriting the entire future of warfare. And once you understand what Mach 12.5 actually represents, you'll realize why the Pentagon's silence might be the most telling response of all. Now, full transparency. Programs like the F-47 exist in the shadowy world of unacknowledged special access programs. What I'm sharing comes from budget analysis, leaked industry sources, connecting dots from congressional testimony, and technical experts willing to speak off the record. Official confirmation? You won't find it. But the physics and strategic implications? Those are very real. And they should concern everyone paying attention to the future of warfare. Let me give you some context for what we're talking about here, because throwing around numbers like Mach 12.5 doesn't really capture the absolutely mind-bending physics involved. The F-47 Blackbird, the fastest air-breathing manned aircraft ever officially acknowledged, maxed out at Mach 3.3. The X-15 rocket plane reached Mach 6.7, but that was essentially a controlled ballistic flight, not sustained atmospheric cruise. Mach 12.5 is in a completely different category. We're talking about speeds where air molecules can't get out of the way fast enough, where friction generates temperatures exceeding 3,000 degrees Fahrenheit, where traditional aerodynamics break down and you're essentially surfing the edge between controlled flight and becoming a meteor. The International Space Station orbits at roughly Mach 23. But that's in the vacuum of space where heat and drag aren't trying to tear your vehicle apart every millisecond. Now here's where this gets really interesting. Intelligence suggests this isn't a rocket. It's not a one-time experimental craft designed to touch extreme speeds for a few seconds before gliding back to Earth. This is an air-breathing aircraft capable of sustained hypersonic cruise. That changes everything. The numbers tell a story that's almost hard to believe. At Mach 12.5, this aircraft could fly from Los Angeles to Tokyo in under 50 minutes, New York to London, 23 minutes. But here's the military application that has strategists completely rethinking defense doctrine. Any point on Earth becomes reachable in less than 2 hours from takeoff. There is no safe distance anymore. There is no time to prepare. Detection means nothing if you can't respond before the threat arrives. Traditional air defense systems are designed to intercept targets moving at Mach 3, maybe Mach 5 if you're talking about the most advanced systems. Mach 12.5 isn't just faster. It's operating in a realm where current defensive technology simply cannot function. Why the silence? History shows the Pentagon only announces capabilities when revelation serves strategic purposes. The F-117 flew for 7 years before acknowledgement. The RQ-170 remained secret until one crashed in Iran. This silence follows a familiar pattern. Breakthrough technology stays hidden until operational advantage is secured. When the SR-71 set speed records, Cold War tensions meant public demonstration served deterrence. The F-22 Super Cruise capability was announced because adversaries needed to know the gap had widened. But Mach 12.5, a speed that redefines what's possible, gets nothing but radio silence. There are a few possibilities here, and none of them are comforting for America's adversaries. First possibility is that what happened was so successful, so far beyond expectations, that revealing details would expose capabilities we're not ready to acknowledge. If this aircraft performed flawlessly at Mach 12.5, that suggests operational readiness. And operational readiness in a hypersonic strike platform changes the global strategic balance overnight. Second possibility is that the test revealed something unexpected. Maybe the aircraft performed beyond its design parameters. Maybe systems behaved in ways that weren't predicted. When you're pushing into unknown territory, you sometimes discover capabilities you didn't know you had, and you definitely don't want to advertise those capabilities until you fully understand them and know how to exploit them. Third possibility and this is the one that keeps defense analysts up at night, is that the silence is strategic. Maybe the Pentagon wants adversaries to know something happened, to know we achieved something unprecedented, but doesn't want to provide any details that would help them develop countermeasures. Uncertainty is a weapon. If China and Russia know we have hypersonic capability but don't know the specifics, they have to prepare for the worst-case scenario. They have to invest billions in defense systems that might be completely inadequate because they're working blind. Let's talk about what achieving this speed actually requires. Because this isn't just about building a more powerful engine. The challenges multiply at every level. First, the propulsion and thermal problems, which are essentially inseparable at these speeds. Conventional jet engines tap out around Mach 3 because air compression in the intake becomes so extreme that combustion becomes impossible. Scramjet technology theoretically allows flight up to Mach 15, but you're essentially trying to light a match in a hurricane and keep it burning steadily, while atmospheric friction generates heat that would vaporize conventional aircraft materials in seconds. The leading edges of the vehicle could be experiencing temperatures exceeding those inside a blast furnace, heat loads so extreme that even exotic materials like reinforced carbon-carbon start to degrade. Whatever solution was achieved, it represents breakthrough technology in propulsion, materials science, and active cooling systems that goes far beyond anything publicly acknowledged. Then there's the structural and control challenge. At Mach 12.5 dynamic pressure, the force of air molecules slamming into the aircraft measures in tons per square foot. Traditional aircraft structures would crumple like aluminum foil, and traditional control, surfaces like ailerons and rudders, moving them into the airflow at these speeds generates forces that could rip them off the aircraft. So how do you steer? Advanced hypersonic designs use thrust vectoring, reaction control systems, even theoretical manipulation of the plasma field that forms around the aircraft using electromagnetic fields. Whatever is being used here, it represents control technology decades beyond anything flying operationally today. So how did they solve these supposedly impossible problems? Here's where it gets interesting. Whispers from the aerospace community talk about ceramic matrix composites that can maintain structural integrity at temperatures that would turn titanium into heat liquid. About fuel circulation systems that turn the airframe itself into a heat sink, absorbing thermal energy before it can cause damage. About computational modeling so advanced it can predict airflow behavior at hypersonic speeds with accuracy that wasn't possible 5 years ago. These aren't just incremental improvements. These are fundamental breakthroughs in multiple scientific disciplines happening simultaneously. But here's what should really concern rival nations. Mach 12.5 might not even be the limit. Aerospace engineers I've spoken with suggest this test may have been deliberately throttled, a demonstration of control, not maximum capability. When you're proving out new technology, you don't push to absolute limits on the first successful test. You validate systems, confirm models, verify that everything works as predicted. The actual performance ceiling could be significantly higher, and that possibility is what keeps defense planners in Beijing and Moscow awake at night. The strategic implications of Mach 12.5 capability are almost impossible to overstate. Let's think through what this means in practical terms. Right now, when military planners talk about power projection, they think in terms of carrier strike groups, forward bases. Aerial, refueling all the infrastructure required to put combat power where it's needed. A Mach 12.5 strike aircraft eliminates most of that. You can base these aircraft in the continental United States and strike anywhere on Earth in under 2 hours. No vulnerable overseas bases, no carriers sailing into missile range, no telegraphing your intentions days in advance as forces deploy. The threat becomes omnipresent and immediate. Consider how this changes deterrence calculations. Right now, adversaries can make decisions based on response time. They can calculate how long it takes for American forces to arrive on scene. They can create windows of opportunity where they act before we can respond effectively. Mach 12.5 closes those windows. There is no safe period. There is no gap between decision and consequence. That fundamentally alters how nations calculate risk. It makes aggression far more dangerous because retaliation isn't hours or days away, it's minutes away. And here's the part that really matters. At Mach 12.5, interception becomes almost impossible with current technology. Missile defense systems rely on detecting a launch, calculating a trajectory, and putting an interceptor in the path of the incoming threat. That process takes time. When the threat is moving at nearly 2 miles per second, when it can maneuver, when it can alter course, the intercept problem becomes exponentially harder. We're potentially looking at a weapons system that's effectively unstoppable with existing defensive technology. That's not hyperbole, that's physics. And the Pentagon knows it. The technology implications extend far beyond military application. If we've solved the hypersonic cruise problem, if we can build aircraft that operate sustainably at Mach 12.5, we've made breakthroughs in material science, propulsion, thermal management, and computational fluid dynamics that have civilian applications down the road. Think about what this could mean for space launch, for commercial hypersonic travel, for satellite deployment. The technologies developed for programs like this could seed entire new industries decades from now. But right now, those technologies are classified because they provide military advantage. And America doesn't give up military advantage lightly. What we're witnessing might be one of those rare moments where aerospace technology takes a genuine leap forward. Not incremental improvement, but fundamental breakthrough. The kind of advancement that historians will look back on as a turning point. The Wright brothers at Kitty Hawk, Chuck Yeager breaking the sound barrier, the SR-71 proving that Mach 3 sustained flight was possible, and now potentially demonstrating that Mach 12.5 is achievable in a practical operational aircraft. These moments don't come often, and when they do, they change everything that follows. The Pentagon's silence tells us they understand the magnitude of what just happened. They're not staying quiet because the test failed. They're staying quiet because it succeeded beyond any reasonable expectation. And success at this level creates challenges all its own. How do you integrate this capability into existing force structure? How do you train pilots for aircraft that operate at speeds where human reaction time becomes a limiting factor? How do you develop tactics and doctrine for a weapon system that has no historical precedent? These aren't simple questions, and they don't have simple answers. So the Pentagon goes silent while the experts figure out what comes next. For America's adversaries, this silence should be absolutely terrifying because it suggests that the gap between their capabilities and ours just widened dramatically. China has been investing heavily in hypersonic weapons, mostly missile systems that touch high speeds during terminal phases. Russia has been making claims about hypersonic weapons that Western analysts treat with skepticism, but sustained Mach 12.5. Cruise in a controllable aircraft? That's a different category entirely. And if the United States has achieved it operationally, everyone else is playing catch up to technology they can't even fully characterize because we won't tell them what we've done. That's strategic advantage in its purest form. Something just happened over the Pacific that redefined the future of air combat. Mach 12.5 isn't just a number. It's a statement. It's a demonstration that America's aerospace engineering capabilities remain decades ahead of anyone else on Earth. And the Pentagon's silence isn't weakness. It's confidence. The kind of confidence that comes from knowing you just achieved something your adversaries won't be able to match for years, maybe decades. The fact that we're still figuring out exactly what that future looks like is precisely why the Pentagon isn't talking, because the next move isn't theirs to announce. It's adversaries scrambling to respond to a capability they can barely yet comprehend. And that's exactly where America wants them.